So let's have a look. We had a look at x squared plus 3x minus 1 last time. Let's go through quickly because I want to do a couple. We need to sketch, do y is less than or equal to minus x squared plus 3x minus 2. Let's try and do this without our calculator. So I want to provide a sketch without using my calculator. What can we do? Yeah. Yeah. So first of all, can I ask, what will, if I do a little kind of sketch myself, like just in the corner so I know what I'm looking for, what will this basically look like? Yeah. Yeah, a parabola, and the way your finger went, yeah, so it's going to cross at where? Do we already know? -2, and it's kind of going to be up here, yeah, like that. So that's just a little sketch just to give me an idea of what I'm expecting. All right, it's not a proper sketch. So I know the -2, I've got to find these 2 points, and how can I do that? We can try completed square form. Okay. Are you all with me? Some people are writing stuff. So what did you actually try to do first, Nick?
I tried to factor it.
Try to factorize first. Does it work?
I don't think so. The way I've done it, I don't think
so. My first step with factorization would be to do what? So I'm taking the negative out. So I'm going to have x squared minus 3x plus 2. So you can already see from that it's not going to work, right? But it does enable me to do what now? It enables me to do completed square form with that one, that bit, right? Yeah? Because remember, I can't use completed square form if I've got more than 1x squared, and that includes, yeah.
Don't you factorize like x minus 2 and x minus 1?
Okay. So factorization is working. So let's do negative x minus 2, x minus 1.
Okay, that's what I did.
Yeah. So my 2 solutions are at +1 and +2. So I've got, but what do I also now need? I need the vertex. I've got to get that in the right place. How can I do vertex? There's 2 ways now.
Wait, how do you know it's a? How do you know it's not an asymptote? How do you know there's no asymptote again?
Anyone? Yeah.
Because it's not a rational function.
Yeah, so we kind of know that a quadratic is a quadratic, right? We know what quadratics look like. Quadratics, if they're positive quadratics, look like that. Negative quadratics look like that. There's no asymptotes. What does linear functions look like? Straight line, like that, like that, like that, like that. Okay. How do I recognize what it's going to be from the function? So a linear will have a highest order of x to the power of 1. A quadratic, I'll know it's going to be that because it's either positive x squared or negative x squared. What will an x cubed look like?
Oh, that thing?
Yeah. Just been doing it with DP1. If I've got x cubed with an x squared component, it just goes like that. It's still roughly like that. Again, no asymptotes. Do you remember what an x to the power of 4 looks like?
Isn't it just it's like a parabola, it's not a parabola.
Yeah, so a bit flatter at the bottom, wasn't it? And then every time we go up, x to the power of 5 goes back to x cubed, but a bit flatter, and x to the power of 6, exaggerated, is, you know, they basically just do that. There's the only thing then is if I add an x cubed component and an x squared component, I end up kind of getting things look like that, right? As we add it up. But none of these have asymptotes. So what functions do have asymptotes? Rational functions. So we've got first type reciprocal functions, which develop into, they're a rational function, but then we've got other rational functions.
Okay, so like if there's a fraction.
There's a fraction, yeah. Then we know we've got asymptotes. There's other function which has asymptotes, which is
Couldn't you turn that function into
no.
something with a fraction?
Well, don't forget, sometimes when we start with a rational function and simplify it, do you remember when we had x plus 3 multiplied by x plus 2 divided by x plus 2? Yeah? Remember, we could cancel the x plus 2's and we're left with a what function? A linear. So this whole function actually looks like that, yeah? Straight line. So although it's a rational function, it looks linear. But what was the problem? Steve-O?
Is it asymptote by x?
It's not an asymptote, is it?
No.
It has a limit in the domain. Where is that gap that's infinitely small?
-2.
At -2, yeah? But this doesn't have an asymptote because what's the definition of an asymptote? What property must it have? There was 2 questions in your test that's led you to the definition of an asymptote.
You always tend towards that number.
That's the thing. It's
never.
it's the tending towards it but never getting it. Getting closer and closer and closer, infinitely close but never actually getting there.
But isn't that not the asymptote? Isn't the asymptote the actual line?
Yes, the asymptote is the equation of the line, but the line that we will never get to. Yeah? Right? But this doesn't have that, does it? It doesn't tend to, well, it kind of does, but it doesn't show the behaviour of kind of moving away, yeah? Getting closer, right? So we've got a rational, but there is another function.
Exponential? Sorry.
Yeah. A to the power of x, where a is a number, yeah? What do they look like? How many asymptotes does it have?
None.
I've just asked another function with an asymptote. You told me this and then say none.
Oh.
That doesn't make sense.
Maybe. No, 1.
It only has one, doesn't it? Horizontal or vertical?
Horizontal.
Horizontal. That axis, yeah? All right. This, a lot of people think that that's also going to be an asymptote, but it's not, is it? Because it will cross and it will go on infinitely. It will just get really, really tall so you won't be able to see it. Yeah. So rational exponential will have asymptotes. Quadratics, linear, cubics, they don't have asymptotes. Only certain functions have. So don't start looking for asymptotes in every function you do. Yeah. So this one, no, it doesn't have a. But we've got our x-intercept sorted out at 1 and 2. Right. Does that negative affect the x-axis intercepts?
No, because the x-intercept is when y is equal to 0.
Yeah.
And so then you can multiply the function, everything by negative, or divide by -1, and it would be
Still,
0.
yeah. So the -1 that we've got there, remember how we find it equaling 0? It's these things have to be 0, right? -1 is never going to be 0, so we can take it out of the equation completely. Because if this is 0, so if x is 2, that becomes 0. The -1 doesn't make it -0, does it? So the -1 does not impact, it doesn't make all your x-intercepts negative. It doesn't do that. All right, that's the interesting thing about the factorized form. But where's the vertex? How can I find the vertex? So there are 2 ways. We could do vertex form like we did yesterday, or
because we have 2 points that are on the same x was the same y coordinate, we can find the line of symmetry.
good. So we've got down here, look, in my little sketch, I've got a line of symmetry, haven't I? And the vertex is on that line of symmetry. What's the x value? X equals, good, 1.5, halfway, yeah? How would I find the y value to go with that then? To find the actual coordinate. It's amazing. This always strikes me as like the easiest question I could ever ask. And it's like, yeah, just substitute in. No. Don't forget what this means. It means the y coordinate can be found by doing negative the x coordinate plus 3 lots of the x coordinate, subtract 2. Yeah? So if I want to know the y coordinate, I substitute the x in. So we can do y equals negative 1.5 squared plus 3 times 1.5 subtract 2. So what's the y coordinate?
It's going to be a plus 4.5 right there, minus 2. Point 0.25, I believe.
Yep. 0.25 or a quarter. Yeah. Right, so I've got some values now that I can put in. My coordinates are, I've got 2, 0, I've got 1, 0, and I've got 1.5 and 0.25. Yes.
But since it's not actually an equal sign, since it's a less than or equal to sign.
But I don't need to worry about that until I've drawn the graph, do I?
But couldn't the y point be anything below that?
No, but don't forget, I'm drawing my line. And what is the line? It's an infinite number of points where y equals it, yeah? Where y is less than is a region, isn't it? But I need to know where they're equal first. So I am drawing this set of points before I can work out the region. So now we've got those coordinates, we're going to do a little sketch. So I'm going to draw my set of axes. I'm going to put mainly sort of like this. The reason I've done that is because I need to put, well, that's negative. We've got a negative 2 as well, haven't we? We've got a 0 and negative 2 point from that value here. So I can put a negative 2 coordinate. I've got a coordinate at 1, 0. So 1, 0. And I've got a coordinate at, oh, that's just rubbish scaling. If I put 2, that's just going to be awful. So what can I do? What would you do?
Maybe like scale it up, so like 1 is 2 and 3.
Yeah, do that, wouldn't I? So I might do 1 there and then 2 there, but that's going to really squash it down. So I'm also going to change this a bit as well.
When you're drawing a graph, do all the scale, like does the y-axis scale have to be equal to the x-axis?
No, it doesn't. Doesn't at all. Just has to be constant on each axis. Yeah. So the reason is I've also, what's my maximum point is only at 1.5, 0.25. So I don't need to put -1 at 3 at all, depending on how I want to stretch it or make it look. So actually I could, if you like, do -2 here, or, you know, do it there. As long as I keep that consistent. So I want to do 1.5, 0.25. So that's going to be 1.5 and 0.25 is going to be here.
Yeah.
Because if that's -2, that would be 1, that would be 2. So 0.5, 0.25. Yeah. So my sketch, so I've got those points. My sketch is going to be kind of done enough at this stage. There's my vertex. I've got the important points. Right. So that line is where y equals negative x squared. What was it? Plus 3x minus 2. So we want what? We want where y is less than or equal to. So can I leave my line as a solid line? So where is y less than? Where's your prediction? Yeah. Below the line. How can I show it? Yeah. So let's take a point that I know the coordinates of. So I know that this point here is 1, negative 2. How can I show that that's in the region I want? Plugging it in. So I want to know, I want to say that negative 2 should be less than or equal to negative 1 squared plus 3 times 1 minus 2. Yeah. So we've got negative 1 plus 3 subtract 2 should be greater than negative 2, yeah? Is it? So I've got negative 2 should be less than or equal to 0. So yes, I'm right. So this is the one I'm allowed. So that would suggest the region that I'm not allowed is above. So I'm going to shade that. Get rid of it. All right. So this here would be my R region. Make sense? Yeah. Okay, that's because they're probably functions that you might struggle with at this stage, especially if we're not allowed a calculator. So let's have a look. Y must be greater than the natural logarithm of x subtract 2 plus 3. Right. So what's it going to look like? So this involves quite in-depth knowledge of lots of functions. So why are you talking exponential? Good. So natural logarithm is the inverse of e to the power of x, isn't it? So hopefully we know what e to the power of x looks like roughly. What does e to the power of x look like? It's an exponential, isn't it? All right. Where does it cross?
2 maybe? Or 1.5?
All exponential functions cross at 1, unless they've got something else added on. Yeah, they'll cross at 1. Where's its asymptote? The asymptote is the x-axis, so it kind of goes up and does this. Yeah. Now, how exactly it goes up? Well, that would rely on, do we remember what e is?
2.7.
2.718, you know, roughly, yeah. But we've got the general idea. So how do we find an inverse graph? Do you remember? Yeah.
It's not very mathematical, but y coordinate becomes x coordinate.
It's perfectly mathematical. But how do I do that on a graph?
By rotating the graph.
Not rotating, but reflecting it. Do you remember we did an exponential, no, sorry, an inverse function is the reflection in y equals x. Because y equals x, if you reflect it, the x coordinate becomes the y coordinate, and that's what happens when you inverse things, right? So what's it going to look like roughly then? Well, roughly my inverse function will be crossing at 1 on the x. The asymptote is going to be the y-axis, and it will do like this, yeah? Yeah? Okay. So that would be the natural logarithm of x. Yeah? All right, so here's where the next stage of our knowledge comes in. I don't have the natural logarithm of x, I have the natural logarithm of x, subtract 2 and plus 3. So what am I applying there, ladies and gents?
Translations.
Translations.
So you'd move the whole thing right by 2 on the x-axis.
Yeah.
And then up 3.
Okay, so remember what we can do then. My focus, when I've got a function with an asymptote, what I should do is put in where my asymptote. So currently, natural logarithm of x, the asymptote is this line here, yeah? Where's it going to go if I translate it 2 to the right and 3 up?
Move to the right.
Just 2 to the right. So I'm going to put my new asymptote line there. It's not very clear, is it? But it's clear on your screen. So I know my line will not cross that line. All right. How does the plus 3 affect things?
Moves it up.
What up?
Moves the...
So every point moves up. So the one point that I know is what? So 1 was where it crossed. But that point here now is at... So it's moved by 2, so it's now at 3. Okay? So it used to cross there, but it now has been shifted up. So that point there is actually. All right? So now my curve is going to actually look like.
It doesn't look the same, really.
Yeah, roughly. Yeah. So that coordinate is now going to be at 3 and 3. And that's the only real coordinate that I need to worry about with a logarithm, Make sense?
Yeah.
So that's the natural logarithm of x subtract 2. So you've just applied lots of things that we've been learning for the last couple of weeks. Inverse functions and translations of functions. Now comes the y has to be greater than that. Yeah, which side do you think? So you think it's the side above. So what coordinate could we pick to be sure?
Wait, 3, 2?
3, 2. That's on this side.
Sorry,
Yeah.
2, 3.
2, 3. Okay. Well, what's the problem with that?
Oh, it's on the asymptotes. We already know it's not.
So there's going to be a problem, right? So should we pick 1 and 3? Because we've kind of got that sussed. 1, 3. So what happens then? So we need 3 should be less than the natural logarithm of 1 subtract 2 plus 3. Yeah, let's do that on our calculator. What's the natural logarithm of -1? Well, actually, we could probably even do it without our calculator, couldn't we? So how can I work out the natural logarithm of -1? Let's say that's my x. Need to figure out its value. What do I do?
E to the power of x is equal to -1.
Okay.
It says the natural log of -1 is not a real calculation.
Mm.
Because
Yeah, you can't have E is what number? Is it positive or negative?
Positive.
Positive. So you can't raise a positive number to a power and get a negative answer, right? So I can already see from this form it's not going to work.
So you have to shade the outside.
Well, that region, does it apply? Do you remember we said last time you can't shade a region if it's not applicable?
Well, why isn't it applicable?
Because y is not, because that value doesn't exist. So we can't say y is greater than something that doesn't exist. Remember we had that?
So, so nothing on
So
the
what
left
should we
of the
pick?
asymptote.
Okay, so we can't take this asymptote, can we? What if we do, let's just check them. Let's do 3 and 6. What do we get there? So we've got 6 should be greater than the natural logarithm of 3 subtract 2 plus 3, right? So then we've got
That equals 3.
the natural logarithm of 1 plus 3. So the natural logarithm of 1 is
0.
0. So 0 plus 3 makes 3. All right? So is 6 greater than 3?
Yes.
So that's what I want, right? So that region I'm allowed. So I'm going to shade under it,
And
but...
then you shade the asymptote area, right?
Okay. So we're not allowed that bit, are we?
Even past the y-axis or no?
The whole thing, yeah. Check, see whether they agree.